Example of a series circuit where you can see that both of these are synchronized by setting the rod end area of the cylinder 1 is equal to the blank end area of the cylinder 2. That way we can have the synchronization like that. Otherwise the cylinder will hydraulically locked after a couple of times. Now check that video where I explain a little bit more details about the series circuit and the equation development. In this example I'm going to show you how to solve problems on this type of circuit. So this is the circuit, this one is the extended stroke, this is extension, and then this is the retraction. So let's go solve some problem on this. Assume that I have this side area about 10 inches square. We can always get the cylinder area. This is 8 inches square. So to be able to synchronize, this must be also 8 inches square. And then this rod end area of cylinder 2 is say 5 inches square. Let's define some points. Assume this is my P1, and then or maybe P1 could be here too, depends. This is my P2 point, and then this is my P3 point. This P3 could be here or here, depends. So when it extending, during extension, I can write that the force on the left side of the first cylinder would be the pressure times the blank end area of the first cylinder minus the force on the rod side, which is the rod side pressure times the rod side area of cylinder 1, which is this. And say that, assume that's F1. So this is the F1 force. This is F2 force. So if this is my equation 1, then for the F2 we can write that P2 times the area of the blank end of cylinder 2 minus P3 times the area of the rod end of cylinder 2, which is this, minus the rod area, is equal to F2. This is my equation 2. If I add these two equations, to make this cylinder synchronization, these two should be exact same. So this area, this force and this force cancel, so I have P1 area of the blank one minus P3 and then the blank end area or rod end area of the cylinder 2 fluid area, and then F1 plus F2. So I can solve for P1, that would be then F1 plus F2, and this part goes on this side, plus P3 area of the blank end of cylinder 2, then area of the rod, so that will give me only the fluid area divided by the area of the blank end. Assume that the F1 F2 is 1000 pound each, plus say I have 50 pound back pressure, 50 psi, and then this whole thing is given 5 inches square in the problem. So 5 inches square divided by area of the blank end of the rod, that is given 10 inches square. So I have calculated that 225 psi. So I need a pump that can develop this much pressure so that I can handle this 1000 pound load during extension of this circuit. Let's solve a problem on the retraction side. Same thing. Retraction flow now goes this way. Let's say assume that this is my P3 again. We're using the same notation, P2, so if you forget you can always go back to the video and check. So for this retraction stroke, I will have high pressure P3. So I can write P3 times the blank rod end area of cylinder 2. So area of the blank of 2 minus the rod area. So that will give me the only fluid area. And then this is the force coming from the rod side. And then there will be force this way because I have that P2. So minus P2 times the area of the blank end of cylinder 2, and that is equal to F2. I'm using the same notation. Now I can calculate F1 by this. P2 times the area of the fluid area of the rod end for cylinder 1, which is piston area minus the rod area. So that will be the fluid area. And then minus the back pressure. So P1 is the back pressure in this case, and then area of the rod end equal to F1. So if I add these two, to be able to synchronize, this area should be exact same as this area. So then the pressure is same, the area is same, they will cancel. So P3 times the area of this minus P1 AB1 is equal to F2 plus F1. If I solve for P3, because I want to know how big, what's the rating of this pump, how much pressure this pump needs to develop to handle that 1000 psi on both of this rod. So if I solve for P3, I can get F1 plus F2 plus P1 AB1 divided by AB2 ABR2. If you want to know this equation more, check that video on series circuit theory video. It explains a little bit more than this here. So let's say it is handling the same amount of force as before, both of these cylinders, and then say I have the same back pressure 50 psi. However, the area is 10 inches square of the cylinder 1 blank area. Divide by this whole thing is given 5 inches square. You can go back to the video and check. So I have solved this one 500 is it 500? I think I got 550 something wrong. Let me calculate that. Yes, that is 500. I don't know what I was thinking in my mind. So that was calculated 500 psi. So for the retraction stroke, I need a little bit more pressure than the extension stroke. So the pump rating at least must be 500 psi or more to handle the series circuit with 1000 pound for each of these cylinders.